Hi everyone. Thanks for coming. I'm Yaobin. I work in a company, a startup company called Code Zero. We actually build digital business cards. I've been using Flutter since maybe 2-3 years ago, like since version 1. Yeah, in my company, we don't really use Flutter, but I use Flutter a lot on my side projects and other projects. So let's get on to so we start from recap. From chapter 7 and 8, we learn about Navigator 1 and Navigator 2.0. There are difference in Navigator 1 is the imperative navigations where you just call push, pop, replace. Well, Navigation 2 is a bit more complex, that you have the opportunity to control the entire navigation state based on the state of your application and also based on users' interactions. So we call that a declarative navigations. It's simple. Navigation 1.0 is a bit more simple than the Navigator 2.0. It depends on your requirements. You can actually mix both of these. So let's say you have a Navigator 2.0, you set up all your navigation states. You still can use push and pop to push new screens onto your screens. Then we also learn about Go Router, a package that written from the community to smoothen the Navigator 2.0 usage rates, and also deep linking. Deep linking is to direct a specific redirect users to a specific screen of your app, such as maybe you are on you caught a link for Lazada that directs you to a specific product page. You click on that link, then this Navigator 2.0 it comes to this steps one, like users enter the new URL, then you pass the informations, you set the new path, you generate a new app state, then your app display that particular product instead of going through the home page, then subsequent pages. Yeah. So in short, Navigator 2.0, we have two paths. One is the app notifies you about a new URL, you pass it, you set the new route path with a new app state. The other way around is, let's say on user interactions, user click on the link, you want to update your app so that your UI reflects the, let's say, products that you are trying to show, and then also update the URL on that address bar of a browser. So this part is most likely only useful in browser platform. Right. Next, we're going to talk about data persistence today, chapter 9. Chapter 9 is pretty short. It's just about how to save data. There are three main ways to save data. The first way is to write to files. So for example, you have to programmatically write a code to open a specific file. You write your data into it. This data can be arbitrary. It's all up to you. It's all under your control. And then you save it. The next time you want to read it again, you read it back, pass your data, and then you do your stuff. So the second way is we use plugins to write into shared locations. This is what this chapter will be talking about. It's going to talk about shared preferences. Shared preferences is the main way to write very simple data. So the underlying piece that run on the native side is the shared preference on Android and also user defaults on iOS. Lastly, there's another way is to use a database. This will be talked about in chapter 15. Database is to store very structured data or data with relationships to each other. we're going to talk about that in chapter 15. So we're just going to take a look into the code. Yeah, so first off, the author of this repo reorganized the codes into features. So now you have features folder, which have this home folder, which is this entire thing. And then you have the tabs, the current tab, the favorite tab, journal, and the recent tab. And also you have a shared features that this usually used to store common widgets that is that is used throughout the apps, and also a splash screen. Yeah. So on top of that, I think these are all the same. So all the navigations related codes are all under navigations, and we also have a model. Right. Okay. So let's go to chapter 9, step 1. All right. So on these steps, what we are trying to achieve is we have an app that we have a favorites tab, which we do not actually we cannot store any favorite stuff over here. What we want to do is we added a favorite button here. When this click, this should update the tab, the list over here. So we're gonna take a look how this button is built. If it's in a podcast, widgets. This is recent imports. Yeah. So here we have the icon favorite buttons. We also have a new provider called Favorites Manager, which manages all these imports that you favorited. If it's a favorited, we're just gonna render it with a red background. Otherwise, it's just a white one. What's interesting to see here is notice that this consumer, if you remember from the provider from few chapters back, yeah, we use consumer to read data that we needed from our state management. Here we read from the favorites manager. Then we just render it based on the data from our provider. What's interesting is this consumer is way down below here instead of all the way on top of here. The reason being is that if I click on anything, let's take a look at Favorites Manager first. Okay. So Favorite Managers is a change notifier. Whenever you add some favorites or you remove some favorites, we call notify listeners. Whenever you call this notify listeners, all the consumer widgets, will be built out. So let's say we have this consumer all the way top here. Whenever the notify listener is called, this whole thing will be rebuilt unnecessarily. So what we are interested here is just this icon here. So we put it all the way down here to save some performance. All right. Yep. So back to Favorites Manager. Is pretty simple stuff. We have add favorites, we have remove favorites. Instead of calling this directly from our import cards, we are just going to use toggle favorites as a public API. If you remember, everything that starts with an underscores is actually private to this a file only, so it's not accessible from the outside. So back to import card. When we tap on this icon, we are just going to toggle the favorites. Yeah. Still makes sense, right? Okay. Next, we are going to check out step 2. Okay, step 2. Okay, yeah. So just now we talk about how to add this icon, this button, and clicking on it should update our favorites manager, which store a favorites ID. Next, so now we are going to display all these favorites items inside this favorites tab. Right, no favorites yet. Click on one. We see one. Right, let's click on the second one. Oh, let me refresh. Something cannot be scrolled. Anyways, yeah. So we are able to save into a favorites tab. And click it again, toggle it again is removed from our favorite list. And let's show our favorites report tab. Just a second, I'm trying to look for, yeah. So in this recent tab, we read from a mock airport service that get all our recent airports. But this is not a very good ideal place to initialize a service. Reason being, whenever this page is rebuilt, your service will be updated every time it builds up. So it will, everything that you've done on the previous build will actually be resetted and no longer persist. Okay, and then so if you see now, I click on the favorites, it appears on my list, but whenever I do a hot restart, it will remove my favorites. Is no longer it's not persisted. So we are going to fix this. Let's check out the next step. Step 3. This is where we bring in the shared preference to persist our favorites airport. Yeah. So whenever you add in a new plugin, so we added a new shared preference in this commit. You have to reboot the entire thing, so you cannot just do a hot restart. We have to rebuild it, as in just stop it and run it again. In the meantime, there's a difference in between the package and the plugins in Flutter. In short, Flutter, a plugin is a code, a library that contains a native set of codes. Like let's say, to do shared preference, we need shared preference from Android natively and also user defaults from iOS natively. So this kind of libraries, we call it plugins. And our packages are more simpler. It's just all Dart codes. What's up? So one quick thing is, if you go to pub.dev and you search for shared preferences, this is the result. It's written from the Flutter team. Whenever you see all these iOS, Android, Linux, Mac OS, these are all the platforms they supported. So this is how another way that how to determine this is a plugin or packages. Yeah, but take note that even though it listed here, in rare cases, I've encountered plugins that they declare they support macOS, but actually they do not. They just listed as they just listed. Yeah. All right. Let's get back to framework managers. What we have added is we added shared preferences. We added shared preferences. We initialize our shared preferences, and then we pass it into the framework managers. Inside our favorites manager, we got that shared preference. We use the shared preference to sync to persist our favorites ID. How do we persist here is that we store a list of IDs that we that the user click on it. As a click on this one, it will store this ID. I believe is ID 1 or ID 0, and cannot scroll. So I just do a hard restart, and I go back to favorites. Now it is stored there. How this works is it takes all these favorites ID, map it into a string, and then join it with a comma. So in the end, it becomes a comma separated value CSV. What map does is it takes the teams of the IDs. Then it supplies these functions to it and call it on every values. So let's say you have an ID of 1, 2, 3, 4, 5. What it does is it takes once and then it converts it to a string, and then with this new array list, it joins it with a comma, so it becomes a comma separated values. 2, 3, 4, 5. Yeah. So this is how we write it right into our shared preferences. To read it back is to do the reverse thing. We get our IDs, which is this one that we stored, and then we split with a comma. So we ended up back with this array of IDs, and then we pass it back into integer. Yep. So this is how the persistent works. Pretty simple stuff. Yeah. So before we move on to the next step, the author actually do a huge refactoring to so that we can easily rewrite our code to use database instead of shared preference if needed. So under we have our favorites manager. Yep. So instead of just passing in the shared preference like we did just now, we instead define a persistent object class to support all kind of persistence strategy. So here we have a abstract class persistence. This is an abstract class that you cannot use directly. You just define what are the functions that is available in this class. And our shared preferences persistence implements this persistence. So and then we implement the functions defined by the persistence. The reason we do that is so that let's say now we want to do an in-memory persistence, we can just redo the copy the thing memory Then we have different kind of, let's say we have capability list of string uh, no, maybe should not demonstrate this one. All right. Okay. Anyway, so we have shared preference persistence and in-memory persistence. We have two kinds of persistence strategy right now, and the favorite manager doesn't even need to know what underlying technique is being used to save to store data. So what it does is just this is going to call persistent. I'm just going to set key, and I'm just going to call get key. So now we need to inject the shared preferences. We need to let favorite managers know that we are going to use shared preferences persistence. Yeah. This is one of the major things that the author write this in prepare for the SQLite, prepare for the SQL persistence. Yeah. So key points is we have multiple ways to persist data. Shared preference is to store very, very simple data, mainly booleans, number, strings. We also learn about plugins and packages. We'll also talk about consumer to be at nearest where the provided data is accessed, and also how to refactor and write manageable codes. Okay, we're gonna take a break and take some Q&A for now. Any questions? So the GitHub. Let's see. Yeah, so now it's scrollable. Thanks, Harmon. So if I click on button, it's going to show up here. Oh, wow. Okay. No questions. We are going to move on. So questions about plugins. You still have to test it on each platform. Yes. To be a responsible developer, you are going to have you have to test on all these platforms that you want to release to your customers or clients. Yeah. If it makes sense, about the rare cases that I mentioned just now, that the plugins does not advertise as they are, it's very rare cases. I think there are some developers or contributors that they misunderstood the requirements to be on to support the platforms. Yeah. If no other question, I'm gonna move on to the next one. It's gonna be pretty huge stuff. All right. So next, we're gonna talk about on chapter 12 database, first half of that chapter. Basically, whenever you need to use databases, when your data is getting more complex, have more relationship with each other. Like let's take e-commerce as an example. We have products, we have multiple products, we have an order list. Whenever we have a cart, whenever you add some products into a cart, you have to keep track of what have you put into the cart, how many items have you put in it, and all these prices, promotion stuff. This is when your data will be a little bit more complex to be stored in a shared preference. So this is where we have SQL, or we pronounce this as a SQL, or we have SQLite, which is explained in the book itself, and also Hive, that is explained in the example, the AirPod app that we use. But having that said, most of the time, from experience, we don't really need to have a database on our app site, mainly because we tend to store data on the cloud right now. So cloud is becoming more common nowadays. And data, well, we're going to read data through API requests. So, yeah. This is our state of our previous app, or the AirPod apps. Our UI is directly dependent on the state and also the data, and the state also knows how the data layer works, where the data comes from. So we are going to do some refactoring. The author is going to do refactoring, which will essentially make that so that the UI depends only on the state, the state of your applications. Let's say the favorite manager state, your what else? The tab states, and then the data layer will only be concentrated on how to retrieve data and pass it back to the state. So we check out chapter 15. There's only one step. While we do that, we're going to take a look on the data contract. Okay. Yeah, let me get my packages. I think not grab my Hive. Right. Okay. So what's new with these steps right now is that we have more abstract classes to define contracts. Contracts like whoever they want to use this piece of code, they have to comply or conform to this contract, so that the user of this class will not need to know the underlying implementation of your code. So we have data contract, we have set items, we have get items, get all the items, get favorites, set favorites, toggle favorites. These are all just definition of functions. The underlying implementations is unknown to the actual user of the app. Is it not wrong? Okay. So we have our data model, which is a model of our object that wants to be stored. We have data contract, the operations that you can work on this data model. Next, we have the source. Source is where the source comes from your for data model. For your, let's say we are going to use Hive as our source. we also can use shared preference as our source. Something is pretty wrong with my, okay. Let me make sure it's this one. Start. Okay, so let's take a look at what is a source. We have a local memory source. What this local memory source is that it extends our source and implements all our data contract. So what you see just now, the get items, set favorites, set items, toggle items, toggle favorites, it implements here. Well, the underlying storage of this thing is actually the favorite ID. Is a local memory set of string. Next, we explore the repository. Repository defines all the source of our data. Let's say we take a look at get favorites ID. Whenever we want to get all our favorites IDs, we check all our source for an answer. So for all the source, I'm going to call get favorites ID. If I found my favorite ID, we're just going to continue. So if we found one ID, we are going to set all our empty sources so that we can do a backfilling of data. Let's say currently we have two sources. We have one local memory source. We also have a Hive source, which is a local persistent source. But if this data is out of sync, it is doesn't make sense for the user. So we try to sync the data between these two sources. This is what this piece of code is doing. So whenever we get something, we look for the item from one of our source. If we found it, we're going to do a backfilling to other sources. So yeah, we do a syncing. Next, we're going to see how to write data. It's more easy. Just going to do set favorites into all our source lists. This is a bit confusing. Right. Next, we have Hive. Hive is a type of database that is mainly used in client side. If you want to know more about Hive, you can take a look in their pub.dev page. Hive is more similar to how Firestore works. It's a database supplied by Firebase, and Firebase is a platform as a service provided by Google. Yeah. So what we do here is we initialize the Hive. Then we create a local persistent source, which we'll take a look into it in a bit. And we are going to declare our repository to have two sources. One is our local memory source, and another is our Hive. Then we are going to put this thing into our APOD service, our mock API service, and also in our favorites manager. So now, if you take a look at the favorite manager right now, now we take a repository of APOD. We're going to call toggle favorites. Whenever toggle favorites is called, we're going to sync it into our persistence and then notify the listeners. So if you take a look at this repositories, it's being called in everywhere. lastly, we're gonna take a look at the persistent source. This is how Hive works. In Hive, everything is you can, our storage is a box. A box is like a folder that you put items in it, you store it inside. So for example, we are going to save some favorites. We're just gonna take our, if it's already favorited, we delete it from our box. Otherwise, we put it into our favorite box. Yeah. And to retrieve it back, we want to get favorite IDs. What we do is we get the favorite box, cast it out to strings, and then back to a list. Yeah. Any questions so far? So yeah, the reason that the author do all these things is that so that next time when we want to pull from a remote data, which is a remote source, we can just do a remote memory source here, a port, yeah, something like that, and we will have another kind of persistent source instead of relying on Hive. This time we rely on network request. Essentially, the favorite manager doesn't need to know what is the underlying storage that is being used. So this is called separation of concern. Okay. So to have a more overview, now our UI depends on our state, which is our favorite managers. And our favorite manager depends on our repository, which depends on different kind of sources. So now we have source one, the local memory. The source two is our Hive, and source three, maybe in the future we will have a remote database or API services. I think we can conclude this. So we learned about from the book. If you have gone through it, you learn about SQLite. Then we saw how Hive works in very general in airport app, and refactoring and how to write a better code. So that's it. Time for questions. Oh, why would people use Hive over SQL? I am not sure actually. I don't really use any local persistency. I put a lot of my data in the cloud. Yeah, I think this is the norm right now. So we can have, let's say now I have another device, I log in, I want to have the same data as in my another device. It has to go through the cloud. So instead of implementing a local storage, maybe it makes more sense to save in cloud. To answer back the question, why Hive over SQL? I believe SQL is a bit harder to work with without knowledge of how database works, because you have to learn about how to do migrations, you have to learn about the SQL language, how to write foreign keys. While Hive is very easy. It's a document-based database. what you store is just, let me go to the airport. Yeah, you just define your airports as the extensive data modeling. You define what are the fields that you want to store and how to convert to and from JSON. And that's pretty much that's it. Yep. Can Hive handle big data? How big data are you talking about? If you're talking about gigabytes, terabytes, maybe no. I'm not sure. But in their page, there's this benchmark thing. It does outperform SQLite and share preferences in read and write. Yeah. 100 transactions per day. I'm not really sure. Transactions, you can have a lot of data. If you're talking about that amount of data, you might probably want to use a remote database. Just take note, this Hive is not the same as Apache Hive. This Apache Hive indeed is a thing that can support large data. It's a data warehouse. Homer got it right. It probably doesn't make sense to store that much data in local persistence. Any other questions? If no, I guess we can conclude and expand.
I was on mute. Thank you so much, Yaobin. I thought it was really good, really clear. Yeah, so no other questions, then let's just talk about, so next week, next Monday, we'll be going over chapters 10 and 11, which is, the topic is networking and serialization. And yeah, I guess and we'll see you next Monday. Right, thanks so much for coming. Any other questions before we leave? Okay, cool. Let me just